you can stack it like Lego. A crew with no heavy equipment can raise the walls of a house in days. The walls are filled with solid concrete. They do not bend, they do not flex, they do not pull apart at the seams. The United States sees more tornadoes every year than any other country on Earth. The average home in Tornado Alley is designed to withstand winds between 90 and 115 miles per hour. An EF3 tornado starts at 136. An EF5 exceeds 200. On May 20, 2013, a tornado more than a mile wide traveled nearly 14 miles through one of the most densely populated corridors in Oklahoma. It stayed on the ground for 39 minutes. Most of the houses in its path were gone in seconds. 2 were not. The material those 2 houses were built from is legal in all 50 states. It is not experimental, it is not exotic. It is not wildly more expensive than the wood frame houses that were turned to splinters around it. And almost no one in Tornado Alley is building with it. That gap between what survives and what gets built is not an accident. It is a design. Here is what most people assume when they hear this. They assume the material must be banned, or unproven, or priced out of reach, or limited to commercial construction. None of those things are true. Insulated concrete forms, ICF, are explicitly recognized under the International Residential Code. They are used in schools, hospitals, and government buildings across the country. Multiple American manufacturers produce them. When you factor in energy costs, insurance, and lifespan, they are cost competitive over time with the wood frame construction that dominates the market. So if it is not banned, not unproven, not unaffordable, and not untested, then why in a state that gets hit by more violent tornadoes than almost anywhere else on the planet, is nearly every new home still built from lumber and nails? If that question bothers you, subscribe. This channel exists to ask exactly that kind of question, and the answers are never simple. ICF was not invented to survive tornadoes. That is the first thing worth knowing. The system was developed in Canada in the late 1960s, in a climate where keeping heat inside a building was a regulatory and economic priority. The concept is straightforward. 2 panels of expanded polystyrene foam, held apart by plastic ties, stacked into the shape of a wall, laced with steel rebar, and filled with poured concrete. The foam stays in place permanently, acting as insulation on both sides. The concrete sets as a single monolithic mass. The system spread through Canada and into parts of Europe through the 1970s and 1980s, adopted largely because energy codes in those countries demanded higher performance than wood frame could deliver. The tornado resistance was never the selling point. It was a byproduct, a structural consequence of replacing a wood skeleton with a solid wall of reinforced concrete. The wind did not care about the original intention. The physics of why it works are not complicated. A wood frame house is an assembly of connections. Studs connect to plates. Sheathing connects to studs. The roof connects to the wall through a series of metal straps and nails. In a violent wind event, the failure almost always begins at a connection. One nail pulls, one plate lifts, and then the system unzips. ICF walls have none of those connections. There is no stud to rack. There is no sheathing to peel. There is a continuous wall of concrete and steel that a 200-mile-per-hour wind has to move as a single object, and it cannot. The physics favor mass and continuity over flexibility and assembly, and this is the part the ICF industry does not always lead with. So pay attention, because it matters. In Moore, Oklahoma in 2013, both of the documented ICF houses lost their roofs. The wood-framed roof systems, the same roof design that sits on top of most ICF homes built in America, failed under the direct EF5 strike. The walls of those houses were structurally intact. The occupants were protected by walls that held a full-size pickup truck that was thrown into one of them during the storm. But the roofs came off. An ICF home with a conventional roof is dramatically stronger than an all-wood frame house. It is not indestructible. A complete solution, one that closes the remaining vulnerability, requires a concrete or heavily reinforced roof system. That system costs more, and almost no residential builder in America knows how to quote it, because almost no residential builder in America has ever been asked to build one. That is not a flaw in the material. It is a measure of how completely the industry has failed to engage with it. So why hasn't it been engaged with? Here is where the story gets uncomfortable. The International Residential Code is the model building code adopted, in whole or in part, by most states in the country. It sets the wind speed design requirements that determine how a house must be built. In much of Oklahoma, under IRC Section R301, residential construction is designed for wind events between 90 and 115 miles per hour, depending on the specific zone. An EF3 tornado, not the worst, not even close to the worst, begins at 136 miles per hour. The code, in much of the region most likely to experience violent tornadoes in America, requires homes to be designed for less than the wind speed of a storm that arrives several times a year. That is the standard. And who shapes the standard? The International Code Council develops and maintains the IRC through a process that allows industry stakeholders to participate in drafting and revision. The American Wood Council, the trade association for the wood products and wood construction industry, maintains a large code advocacy and standards operation. Its institutional interest is straightforward. Wood frame construction is the default, and keeping it the default requires that the code continue to reflect wood frame assumptions about what adequate construction looks like. That is not a secret. It is how standards bodies work. The problem is not that the lumber industry advocates for itself. The problem is that no equivalent force advocates for the family in Moore, Oklahoma, whose house is built to a standard designed for a wind event that a moderate tornado already exceeds. After the 2013 storm, the city of Moore updated its local building codes to require stronger construction. The national IRC did not change. Moore changed its code. The country did not. That is not an oversight. That is a choice. The code is only part of the wall. Even where ICF is legal, and it is legal everywhere, it faces a second obstacle that is in some ways harder to overcome. Banks lend against comparable sales. Appraisers establish value by looking at what similar homes in the same market have sold for recently. In a market where nearly every home is wood frame, an ICF home has almost no comparables. An appraiser with no data cannot support a value. A bank with no supported value will not issue a mortgage. A builder with no mortgage market will not build. The cycle is self-reinforcing and invisible. It requires no conspiracy. It requires only that the system do what it was designed to do, which is replicate itself. If you want to see this made concrete, look at what happened on the corridor that took the direct hit from the 2013 storm. Post-disaster, engineers from Reward Wall Systems, one of the ICF manufacturers whose product was used in both surviving houses, traveled to the site and documented what they found. A neighborhood reduced to bare concrete slabs, the geometry of former foundations, the only evidence that homes had stood there. And in the middle of it, walls still standing, a pickup truck embedded in one of them. The granary and outbuilding on the same property, gone. The wood frame structures on either side, gone. The ICF walls, intact. The findings were published. The National Code body was not moved to convene a review. The walls held a pickup truck. The mortgage system couldn't hold the appraisal. It needs no replacing. That is exactly the problem. So what do you actually do with this information? The first thing to understand is that ICF is not a fringe option. It is manufactured by multiple companies, Nudura, Logix, Fox Blocks, Reward, among others, each of which maintains a directory of trained and certified contractors. It is already used by FEMA in the safe room programs it recommends for exactly the region we are talking about. The federal government, the same government whose building code apparatus has not moved the residential standard to match the actual wind threat, already builds its storm shelters out of reinforced concrete because it knows what survives. That is worth sitting with for a moment. The entry point for most homeowners is not the full house. It is the safe room. A poured concrete or ICF safe room built to FEMA P361 specifications is the one space in a wood frame home that a violent tornado cannot reach. From there, for anyone building new, The path to a full ICF structure runs through a licensed engineer, a manufacturer's installer network, and a conversation with a lender about whether they will treat the reduced insurance risk as an asset rather than an unknown. Some will. More will as the comparables accumulate. Type tornado in the comments, and I will pin a map showing wind speed design requirements by state against actual EF3 or greater tornado frequency by county. See where you live on that map. See what your home was designed to survive and what the sky above it actually produced. Come back now to the image that opened this. 2 houses standing, bare slabs on either side. A pickup truck in the wall, walls intact. And then, after the storm, the harder fight. Trying to sell a house that the market did not know how to value. Trying to get insurance on a structure that no actuary had modeled. Trying to explain to a bank why the house that had just survived the worst tornado in Oklahoma history was worth lending against. The house survived of everything the storm threw at it. The system was harder. This is not a story about a building material. It is a story about what up to code actually means, and who wrote the code, and what they needed the code to protect. If that question belongs in more conversations, subscribe. Every person who follows this work makes it harder to keep the answer buried. The code wasn't written to protect your house. It was written to protect the supply chain.